Page 418, continuing lesson 1, solving problems involving scale drawings. Top of the page in the key concept just kind of recaps things. And just to mention, this part here is an example of a scale. So some of the problems, if you're doing a problem and it asks you what the scale is for something, this is going to be an example of that. For the scale, you want to have this first part have a 1 with it. So like 1 inch equals something, or 1 centimeter equals something. When you give a scale, you don't want to say like 5 centimeters equals this, or 1 1/3 inches equals this. It's not nice numbers to work with if anybody's going to figure out any other numbers based off of your scale. So just give them a nice scale. 1 inch equals something, or 1 centimeter equals something. So let's look at the do you know how number 4. Question, what is the actual base length of the triangle depicted in the scale drawing? So base length, the base is the number at the bottom here. And we are trying to find the actual base length. So for this problem, depending on how you want to do this, one option you always have is to start with your scale. So 1 inch is 2 meters. And then your other part of your proportion, you can put what you know. In this case, we know the 2.5 inches is the model. So we'll put that up in the numerator across from the other inches. Okay, if you do a proportion, always put your same units across from each other. And then we're trying to find the number here. In this case, we do have a pattern. It is multiplying by 2.5. And then that would be 5 meters. If you're able to figure these out, anytime they give you a nice scale like this, 1 inch equals something, 1 centimeter equals something, you're always going to have that nice pattern. So if you're able to figure this out without using a proportion, that's okay. But make sure you write down what it is that you did. Do not just write down the answer, because we know correct answers are worth half credit with no work to show of what you did. Number 5, what is the area of the actual square window shown in the scale drawing? So we've got several important pieces of information here. Notice on this problem they're asking us to find the area. Importance is that it's a square window. Why is that important? Good. All the sides are the same, because if you'll notice on this picture, they've only given me a measurement on the bottom. If I need to find the area, remember, area of a rectangle is length times width. So I have to know what the length and the width are in order to find that area. So on this one, with our scale, if you want to do a proportion here, you can. If you want to just kind of look at it and see what's happening, if you get the hang of these, they gave us a nice scale to work with here. So it would be multiplying by 75 hundredths, 0.75, 1 times whatever number is going to give you that number. So when you multiply that, it's going to be 1.5 meters. Since we do have a square window here, length and width are both going to be the same. So once we get that, we can move on to our second step up here, which would be the length and the width are the same. So length times width is our area. So 1.5 times 1.5, which is 2 25 hundredths, 2.25 square meters would be the area of the window. Workbook page 97, number 1, they're asking what is the actual length of the truck. So the truck, they have graphed this on graphing paper. And if you look at this truck, they're giving us the scale here is that 1 centimeter is equal to 1 7/10 feet, and the grid lines are spaced 1 centimeter apart. What that means is that on one of these squares is 1 centimeter by 1 centimeter. And that's generally the case if you ever use graph paper. If you ever measured a graph paper square, usually that's the case, is they're 1 centimeter by 1 centimeter. You might find some variations, but that's pretty standard measurement for those. So to find the length of the truck, what we want to do is look how far it is from the back bumper to the front bumper here. So if you count in between those two, if you count the squares, that would be a total of 12 squares. And like I said, the squares are 1 centimeter by 1 centimeter. So if you have 12 squares, that means that distance is 12 centimeters. So different ways to do this then. Once you get to that point, you could just say, well, if we know what 1 centimeter is, 12 centimeters is going to be 12 times as much as that. Again, you won't always be given a nice scale, so just to make sure you're aware of it, you always have an option of finding a proportion, and then when you work that out, and then you should get 20 4/10. So 20 4/10 feet would be the length of the truck. Number 3, we've got a 12-foot wall that measures 2.5 inches on a scale drawing. And then we have a second wall that's 9 inches long. And the question is, what's the actual length of the second wall? When you guys are doing problems like this, notice it's talking about 2 different walls here. So if you want to use colored pencils, or like a pen and a pencil or stuff like that, to kind of give a little contrast when you underline and stuff like that, that's fine. So on this problem, notice they're not really giving us a scale or anything. There's different ways you guys can work through this problem. Depending which way you work this problem, you might get your answer a little bit quicker, or it might take you a little bit longer. But there are definitely 2 distinct ways that we could figure out the answer for this one. One way of doing this problem, the quicker route for doing this problem, would be to do a proportion. If you haven't done any proportions because you always had nice scales, this is why I've been talking about them, because things don't always work out as perfectly if they don't give you like 1 inch equals something, or 1 centimeter equals something. So this one, 2.5 inches over 12 feet, that's for our first wall that they talked about. The second wall, we know the 9 inches on the model, but we don't know what the length is, the actual length. So you want to put an X there, you want to put a different letter there, that's fine. This proportion will allow us to figure out what that actual length is. Once you have this set up, if you look for a pattern here, if you take 9 divided by 2.5, you get 3 6/10. That tells us, since this is getting bigger, that would be multiplying by 3 6/10. And then we'll do the same with our denominator. So 12 times 3 6/10, you get 43 2/10, so 43.2 feet. A different way you could do this problem would be to figure out a nice scale. So they gave you 2.5 inches equals 12 feet. You could actually divide both of those. Divide both of those by 2.5, and then that'll tell you 1 inch equals 4.8 feet, and then from that point you could take 4.8 times 9, and you'll get the same answer. So different routes, different ways of doing it. Either way is fine. Look at number 4. In a scale drawing, the length of the rectangular room is 6 inches and the width is 3 inches. And the actual length is 18 feet. So the first question is, what is the scale? If you look at the information they've given us the information of both the drawing and the actual for one of the two things. Which one did they give us for both of them?
They gave the length of the room in feet and the length of the room in inches.
Good. So we know based off the length, we know 6 inches is equal to 18 feet. Now, when we give that as a scale, we don't want to just say 6 inches equals 18 feet. We're not going to leave it like that. We're going to make things nice so that if somebody's using this, which we're going to be using maybe, then it's going to make it easier for them to work it out. So instead of 6 inches, I'd like to know what 1 inch is equal to. So if we divide both of these by 6, tells me 1 inch would be equal to 3 feet. So 1 inch equals 3 feet is the scale of the drawing. On part B, we have a new scale of the same room, and now we've got the length is 4 inches. And the question is, what is the scale of the new drawing? Well, it's 4 inches on this drawing. The actual length is still what? 18 feet. Again, we're not going to leave it like this, so we can divide both of these by 4, and then our new scale would be 1 inch equals 4.5 or 4.5 feet. Number 6, let's look at the information here first. Carpet costs $1.50 per square foot, including the cost of installation. So we're going to have somebody put it in, make sure it gets done right here. How much will it cost to carpet the entire living room floor of the cabin shown at the right? Okay, so notice we do have some extra stuff here. If we look at the picture, first of all, I'm going to take note of the scale here. 1 centimeter is 4 feet. Grid lines are 1 centimeter apart like we had in the last one. So each square is 1 centimeter by 1 centimeter. And again, we're going to focus on what room here? The living room. Okay? So all I really care about is the living room. The rest of this I don't really need for this problem. So first thing we want to do is look at the dimensions of our living room on this model. Going across, this is 3.5 or 3.5 squares, so 3.5 centimeters. And the other direction, it's going a total of 5 squares, so 5 centimeters would be our other dimension on the drawing for the living room. So we're going to need to do some proportions now or something somehow to figure out what our actual dimensions are. So if we look at the 3 5/10 centimeters, I'm going to call that the width because it's the shorter dimension here. Usually the length we'll call the longer dimension. So this is a pattern here is multiplying by 3.5. And so then we'll multiply 4 by 3.5, which is 14. So that means the actual width of the room is 14 feet. I'm going to label my work here because I got a few steps here. Then we can find the length Same idea, only the length we've got on our drawing is 5 centimeters. Maybe do a cursive L so it doesn't look like a 1 if you want to use that. So multiplying by 5, our length would be 20 feet. Good. Alright, so we're going to next need to find the area. They tell us how much it costs per square foot. Square feet always has to do with area, so area of rectangle, length times width. So we'll do 20 times 14, which is 280 square feet. So the area is 280 square feet, and then we know it's $1.50 per square foot. So then the last step, we do 280 times $1.50. $420. Good. So $420 for having somebody install our living room carpet here. Number 7, we have a floor plan where 1.25 inches represents 2 feet. So thanks for not giving us a nice scale, right? What is the actual length of the entire floor? So actual length, if you look at this all together, the length overall would be what on our drawing? 12 inches altogether if you just add the 4 and the 8 together. So we've got 12 inches. Now, don't be tempted to say that that's 1 foot, because that's on our drawing. We want it to stay in inches. Okay? Now, even though this doesn't look real great, there is a pattern here. If you take 12 divided by 1.25, it's not the greatest pattern ever, but 9.6. So tells me we can multiply by 9.6, and then that would be 19.2 feet. 19.2 feet would be their actual length. And then part B asks what the actual area is. In order to do that, first we would have to figure out what the actual width is. Good. So on the picture, the width is what altogether? The width is 10. Okay. Again, this doesn't look real great, but this is actually multiplying by 8. If you do 10 divided by 1.25, you get 8. So the width would be 16. And then the area would be multiplying together. So you do 19.2 times 16, which would give us an area of 307.2 square feet.